the high-speed boat glides across the water with an aerodynamic design and perfect hydrodynamic performance. The project begins with an abandoned scrap jet ski. The composite hull and gel coat have severely aged. Starting the disassembly, the mechanic removes the mechanical mounts, the hood, and the front component compartment. He uses an impact driver to remove the exhaust pipe, then drills out the rivets, securing the hull seams. An angle grinder cuts through large sections of FRP, creating a gap in preparation for structural separation. Using a large crowbar, he applies leverage to tear apart the adhesive layer pressed between the two hull halves. After prying off the deck, the edges of the lower bow are cleaned up. The engine bay is left empty with waterlogged foam. After prying off the deck, the lower bow is cleaned up, and the waterproof rubber seals are stripped away. Prying the bulkhead with a screwdriver, the drive shaft is pulled out of the mounting assembly after loosening the nuts. A steel hammer strikes a wood chisel hard, creating an impact force to break the rusted bond of the clamping flange. Using a socket wrench to remove the large nuts, he completely dismantles the remnants of the old exhaust assembly. The hull is tilted as a crowbar pries off the washer and locating mounts of the rear jet pump assembly. Continuous hammer strikes completely detach the cast aluminum bracket from the crumbling fiberglass hull. Flipping the chassis upside down, an angle grinder equipped with a flap disc sands down the hydrodynamic ridges. This process grinds smooth the gel coat, erasing the original bottom structure in preparation for a flat hull layer. The mechanic continues using the grinder to cut and shape a black plastic block, forming a new bulkhead. Scraping off impurities inside the hull creates the best contact surface before applying the core layer. The hull frame is now filled with yellow polyurethane foam, serving as a lightweight structural core. A wide blade knife decisively cuts the PU foam layer, creating the ideal curved profile for the boat's outer hull. The smoothness of the foam surface determines the amount of putty needed for the subsequent molding stages. Moving on to measurements, a specialized utility knife makes precise cuts on the PVC foam boards to shape them. The PVC core pieces are bonded with cyanoacrylate adhesive, assembled to form an aerodynamic structure for the upper deck. A layer of epoxy resin is brushed evenly onto the shaped foam surface, creating a strong adhesive primer layer. The mechanic lays each woven fiberglass mat on top, carefully covering the entire deck frame. Using a specialized steel roller to press firmly on the surface, forcing air bubbles out of the composite matrix. Once the exothermic curing process is complete, the rough surface is fully covered with putty. The orbital sander operates at full capacity, sanding down the excess putty to create a perfectly smooth surface. The longitudinal aerodynamic contours gradually become clear as the mechanic continues applying epoxy resin in tight corners. A pneumatic spray gun applies a layer of waterproof gray primer, highlighting any surface imperfections. Fine, wet sandpaper is used to manually sand the primer, ensuring proper adhesion for the paint layer. The glossy finish coat is sprayed on evenly, creating a brilliant mirror-like effect for the hull. With the bottom surface finished, the hull is flipped right side up. The grinder continues cutting slots to install the steering system. Digital calipers accurately measure the distance, marking the hole center for the drive shaft installation. A large hole saw drills through the composite bulkhead, creating a perfectly straight passage for the jet pump assembly. The CNC milled aluminum alloy engine mount is test fitted into the engine bay to check for proper alignment. The mechanic uses marine structural adhesive to permanently bond the load-bearing longitudinal stringers to the inner hull. Fiberglass is once again reinforced in multiple layers over the stringers, forming a unibody skeletal frame. Assembling the jet pump. The waterproof rubber gasket is lubricated with silicone grease and slides smoothly into the tail mount. The corrosion-resistant 304 stainless steel bolts are tightened with a torque wrench, pressing the jet assembly securely against the hull. The drive shaft is lubricated and carefully threaded through the water seal system to connect with the jet impeller. The flexible coupling is tightened, ensuring smooth power transmission from the engine down to the water pump system. Moving to the cockpit, carbon fiber boards are finely cut to make the display dashboard. Holes for the tachometer and fuel gauge are carefully drilled using a step drill bit. A leather-wrapped sports steering wheel is attached to the steering column, securely fastened with hex bolts. The throttle and steering stainless steel control cables are routed along the hull to the rear. The creator tests fitting the gaming chair into the cockpit to fine-tune for the optimal seating position. Using a tape measure and an angle grinder, he precisely cuts the composite hull panel, checking the actual steering wheel tilt angle. He marks the steering column's mounting position with a pen. The steering column is modified by welding on triangular steel plates to increase load-bearing strength. Square steel tubing is cut and shaped to form a reinforced load-bearing frame along the hull. He arc welds the frame in place, then applies a coat of black anti-rust and waterproof epoxy paint. The propeller shaft support base area is carefully painted red for protection. Returning to the exterior, the mechanic sands down the previously applied uneven putty surface. A spray gun applies a black base coat, followed by a silver gray coat over the entire hull. He uses a mini rotary tool to accurately carve a half circle on the edge of the bow. Assembling the ultra-bright BI LED lens unit, which serves as a high-beam headlight for the night. The rear open compartment is then coated with black epoxy resin to reinforce the fiberglass. Cleaning the flange with an alloy grinding bit, he welds and sprays heat-resistant paint on the exhaust pipe. The jet pump unit is painted an eye-catching red, and silicone sealant is applied to the flange to prevent leaks. The water intake grate is sanded and sprayed with black paint for corrosion protection. Drilling holes to screw and secure the impeller unit, trim tabs, and cooling tubes. 1. Installing rubber gaskets and small metal parts, using pliers to ensure a tight mechanical fit. 2. Connecting the throttle cable to the carburetor and wiring the remote control relay circuit. 3. Wrapping fiberglass thermal tape around the exhaust to prevent heat radiation from damaging the hull. 4. Wiring the ignition coil to complete the 2-stroke engine bay and placing the 12 volts battery. Drilling small holes along the edge of the hull using an angle square to ensure even spacing. Chamfering the hull edges, he continues applying resin to bind the composite fibers for extra rigidity. An angle grinder is used to cut and shape plastic panels, fitting them perfectly into the tail fin positions. Using specialized adhesive to secure the corner edges, increasing the hull's surfing surface area. A rotary Dremel tool mills grooves along the body, creating slots to install luminous LED trim lights. Using wet sandpaper to smooth out the gel coat, he wraps it in plastic masking, so the pneumatic spray gun can apply a jet black base coat. A metallic silver coat is sprayed on with a gradient effect, creating contrasting aerodynamic block effects. Masking tape creates a sharp line for the racing red, stripe sweeping down from the bow to the stern. 4. The air intakes and wings are sprayed bright red, highlighting the wing structures just like an F1 car. Peeling off the protective plastic layer reveals a flawless, perfect paint finish after drying. Securing the decal logo and Kano Formula 1 lettering using a plastic squeegee, he presses it firmly to remove air bubbles. Tightening the hex bolts, he installs a pair of CNC aluminum rearview mirrors, solid and anti-vibration. 4. Drilling and cutting the steering wheel dash panel, he routes the wiring and mounts the analog fuel gauge, 5. Crimping the fuel float sensor signal wires into the waterproof connector behind the gauge, 6. Finishing the steering wheel center assembly, he tests the 12 volts wireless relay circuit using the remote key fob. Routing the flexible neon LED strips into the milled grooves on the hull sides, he applies superglue to secure them permanently. Finishing the faux exhaust logo, the 2-stroke engine bay is now fully electrically wired. Testing the side lighting system, brilliant white LED light shines from the air intakes. 2. U-shaped aluminum LED channel strips are covered with light diffusing acrylic tubes to create a matrix daytime running light strip. Pasting chrome mirror film onto the faux air intakes, creating a profound sense of mechanical depth. applying a fierce falcon eye decal to the side, completing the aesthetic speed accents. Soldering ultra-bright SMD LED strips, fitting them into rectangular plastic housings for the warning taillights. Pushing the boat out of the workshop on a custom cart, wiping and polishing the clear coat surface. Pressing the remote to activate the central biled and the blue trimmed eyelid strip. The masterpiece is ready for launch. The camera pans across the two-stroke engine block, the CDI ignition system and the coolant hoses. The 4 vacuum fuel pumps are in action, feeding fuel into the carburetor, an aerodynamic view of the boat's rear. The engine roars on land. Exhaust gas blasts powerfully through the pipe. The exhaust is wrapped in a safe thermal insulation layer. The creator sits inside the F1 cockpit. The engine responds nimbly to every pull of the throttle. A leather-wrapped sports steering wheel provides optimal steering angles. A 12-channel remote controls the electronic systems. 2 composite superboats leave the workshop on trailers. The V-shaped hull promises great wave slicing capabilities. Successfully launched into the water. The engine roars as the jet pump sucks in water and compresses it to propel the boat forward. The aerodynamic fin design presses the hull firmly down, preventing it from flipping during high-speed sharp turns. A first-person view showcases the speed. The bow pitches up perfectly thanks to the sloped angle of the hull bottom. The jet propulsion creates a trail of white foam. The ultralight FRP hull optimizes the power-to-weight ratio, taking corners smoothly. The rear stabilizer wings perform their hydrodynamic duties perfectly. The creator has completely mastered the machine. The smooth drive shaft operates with absolutely no signs of RPM slip. As night falls, the machine turns into a spaceship. The vibrant neon LED strips cast their reflection on the river. The BI LED lights pierce through the darkness, combined with the glowing red taillights to create a strong visual effect. An excellent fabrication project born from scrap, proving top-tier mechanical modification skills.